Thank you very much. It's great to be here. So the current method to teach technical skills are to see one, to do one, and to teach one. However, this is really not ideal. The advantages of see one, do one, teach one include guided training with staff, real-time exposure, and an immersive experience. However, the limitations are compromises patient safety, puts pressure on trainees, and does not allow the trainee to practice over and over. Multiple studies have shown that approximately 50% of errors are due to lack of technical competence. Current solutions before first patient contact include high-fidelity simulators. However, these are hospital-based, they're expensive, they only allow for single procedures, and there's a constant evolution of this technology. At Mass General Brigham, we recently started the MGB MXR lab. The purpose of our lab is to explore the applications of virtual and augmented reality in medical training and clinical care. Here is an image of a video of one of our colleagues recording a first-person view of our procedures. So we recorded all of our interventional radiology procedures this way. We then presented them to our students using their own devices, so they're able to see the videos on their own devices. And this is what they see. They're able to look around the room. They're able to see everything that's in the room. I'm able to ask them questions about the CT scanner and how it's used for IR procedures, the monitors, the ultrasound. And so they're learned even though they're not actually in the environment. But that is just passive viewing. What about interaction? So we recently built this VR CT liver biopsy module with funding from CRICO. This allows one to actually put a headset on, and you're able to practice all the different steps of a CT-guided procedure. So you're able to grab the scalpel, make an incision. You're able to grab the coaxial needle there, put it in location. It actually measures the actual accuracy of the angulation that you choose based on the images that you see there. So we've now been testing and validating this module, and this is one of our researchers testing one of our residents. We've been collecting data on the time, the accuracy of needle placement, the complications, and answers to questions. And so I get an output that's like this, which is, was a correct CT slice chosen? Yes. The number of scans that were needed to place a coaxial needle, 4. If there was more, then there's an issue. Accuracy of needle placement, 98%. Total procedure time, which is measured, which is an indication of how successful you are with the procedure, and then any complications, none. So early data suggests that technically proficient trainees had higher technical scores, and knowing their scores allowed the trainees to practice more and more. So what are our next steps in our journey? We'd like to build a library of VR training modules that we could license throughout the world. But there's one more thing, and I just showed you a case of a single person training. What about team training? So what do you need for team training? You need more than one individual. You need a space to move around. You need to interact amongst multiple individuals. So the ideal setting for this is really in science fiction. Star Trek, holodeck, I don't know how many people have seen Star Trek, but that's where you enter a room and the digital environment allows you to be immersed in a completely different environment. So it turns out that's a reality here in 2024. There are actual gaming systems that allow you to actually walk into a room and play a game. And so this is a company called Sandbox, and they have multiple rooms where you can actually walk in and play a game. And so the individuals put ankle bracelets, wrist bracelets, headsets, and then they walk into a room and they interact as a team. So I took a scouting trip to Minneapolis to assess the application of this gaming for medical training. And so you can see here I am wearing my ankle bracelets and my wrist bracelets. And here's a video of me in real time, and there's what I see when I'm in the environment. So again, real me and the virtual me. And so you're able to interact in the environment. So the room design is actually quite basic. There are fans that essentially provide simulation of the wind. There's cameras that track the different bracelets, and then multiple routers. So we've designated a room in our lab that allows us to build the first pilot medical holodeck. But ultimately, this is part of the greater vision that Mass General has to redefine medical education for the 21st century. We now have something called the London Learning Hospital that allows us to essentially create replicas of our ORs, of our ERs. And so my hope is that one day we will have a medical holodeck in this new building. So the next steps are to build, we've now completed the CT liver biopsy module, and it's currently being validated. We're now planning on the holodeck. I'm seeking about 5 million. 1 million will be to build the library of VR modules that we'd like to spread worldwide, and 4 million to build the first medical holodeck in the world. So I invite everyone here to come to the booth here. We have a booth where you can perform your first CT-guided liver biopsy. Thank you very much.